Hey everybody, this is Shawn Hilton with Skiwi. I just wanted to go do an overview of the material and the process we use during the pipe bursting method. It's the high density polyethylene pipe. It's common in the industry. It's what a lot of contractors use. It's the manual fusion process, nothing fancy. We're just going to show you the basics of the fusion process, go over a couple of things, show you some of the ways that we challenge the joints to make sure we've got a good sound weld, and just go over a couple other things. This is pertaining strictly to just gravity sewers. It gets tested at 5 psi. However, at the same time, this pipe, it's put under a lot of stress when you pull it through a hose pipe that's been in the ground for maybe 50 years. The common tool like ours is in the industry. A lot of the contractors around us, we've got a 30-ton tool, and it can pull it pretty hard, so it can be put under some stress. So you need a good sound weld that'll hold pressure, and it needs to be able to endure the stresses of installation. So anyway, without any further ado, let's just get into it. Okay, so here we have a basic manual fusion equipment set up. We got the carriage on the right holding the pipe, and then we've got the facing tool and the heater tools on the left-hand side. First thing we're going to do is we're going to come down and get about a 1-inch stick out in the carriage. This leaves enough room for the facing tool and then later the heating tool to be inserted. After we get about a 1-inch stick out, we put the clamps on, start tightening it down by hand. Just get them close, snug them up a little bit, kind of get a look at it, make sure that it's going to clamp down with even force, tighten it by hand, and then follow it up with a wrench. Just even pressure. You don't want to egg shape the pipe. There we go. Couple turns on there. Like I said, it doesn't have to be very tight. Just enough to hold it so it doesn't move during the process. After that, we put the long handles in the carriage, loosen the knobs on the side, slide it forward, make sure our high-low is going to be what we need. It can't be any more than 10% high-low of the OD wall. After that, if that's acceptable, we put the facing tool in, do a couple revolutions there. We cut off a couple of ribbons. Then we slide the two pipe ends together after we remove some ribbon shavings out of the way. Make sure the high-low is good. Verify that again, and then also make sure there's no gap in there. After that, we come over and we clean the ends with a solvent. You don't want any oil, any grease, water, any contaminants like that. So we clean it up really good, make sure it's as clean as we can get it. Then we come over. We've got a temperature indicator on the equipment that tells the temperature of the hot plate, but it's not always accurate, so you need to independently verify it with a pyrometer. That just for this particular one, we got the hot plate at 425. It needs to be between 400 and 450 degrees, depending on the pipe manufacturer's recommendations. So put the heater plate in, push the two pipe ends together. You don't need a lot of pressure here. You just get a little bit of pressure, then lock the knobs in, and then you're in a holding pattern. For this particular pipe, this is SDR 17. It calls 4-inch. It calls for a 3/16 weld bead. So when each pipe end melts out to 3/16 inch wide, that's when we would pull the heater plate out and push the two ends together and complete the fusion. So we're kind of in a holding pattern here, waiting for that to happen. Getting a good look at it. This just comes with repetition. Loosen the knobs. Quickly get a good look to make sure the melt is good. Push the two ends together with force, and you need to do it quickly. And when you push them together, you want the OD bead to roll over and touch the OD of the pipe. After you get that, you lock the two knobs and let it set and let it cool till it reaches ambient temperature. And that completes the fusion process. Here's an example of a successful weld. This one we made a previous video on doing some stress test on it. As you see, the manual fusion process is not real complicated. You just follow some basic guidelines, adhere to the pipe manufacturer's recommendations, and independently verify that your hot plate is the temperature that it's supposed to be. and you should get consistent joints. However, this is just the tip of the iceberg. The industry can get fairly in depth with really expensive, really large fusion equipment. A lot of it's more automated, data logging that keeps records of it. You don't even do a real joint until you do a coupon, so you basically do a practice one every day before you begin to verify that it's you're getting quality joints. So there's a lot of math behind it. Here's one manufacturer's recommended welding perimeters using their equipment. They've already done all the math for you. This is for 4-inch pipe. If you follow these perimeters, you should have a successful weld. However, they may have to be adjusted due to field conditions. Here's an example of a good fusion, successful fusion joint with manual process. This is one we did. On this next photo here, this is one unsuccessful improper fusion. The ID bead, you can see there's a slight hairline crack in the top right-hand corner. This side-by-side comparison here give you a better visual. On this next photo, you'll see this is what happens if you don't double check your hot plate to make sure that you got the proper temperature. This one was fused at 380 degrees. However, the indicator showed that it was at 425 degrees and it broke. ASTM is the regulatory body that sets the guidelines and the standard for pipe fusion. And it varies greatly depending on the application and the industry. Like us, we're talking about gravity-fed sewer lines that are tested at 5 psi. They also regulate other industries with pipe fusion, gas lines, pressurized water lines, you name it. They also set some standards for destructive testing. We do a lot of our own testing here at the shop. We challenge it in several different ways. We bend it, twist it, pull it, yell at it, several different things just to validate that we got a good process. Here's an example of a coupon that we compressed in a vise. The main reason we do destructive testing like this is just to create repeatability for a successful manual fusion process that we can teach. This is a previously posted video of a successful weld that we put under stress. We bent it right at the joint and then hit it with some impact to see if we could get it to fail. This last video here, this is just to show basically the durability of high density polyethylene pipe. This is still SDR 17. We run over it a couple of times. We actually park on it here for a few seconds. This is some tough material. This piece actually went slightly oval after we sat on it for a little bit. We threw it out in the sun. It's got good memory to it. It regained its shape just from the heat from the sun. And that's it. I hope you all enjoyed the video. If you had the patience to watch the whole thing, I appreciate it. We just wanted to get you familiar with the process and the material that we use. And if you got any questions, you can put them in the comments. We hope you have a good day, and we'll see you on the next video. Thanks.